because she was in contact with someone.
All right, it is time to review the 3.2 worksheet, so let's get started. Hopefully you can hear me as we go over this. So questions on 3.2, not part 1.
I know, can I have the I wasn't here last time.
Yes, you can have the worksheet. Gotta figure out if it's on top or I know. Do you have one? Anybody else need one?
Yeah, I gotta put my other one here.
All right, guys, the only way that this is going to work is if we stop losing our worksheets. Or I guess maybe we should go to IXL. This unit is really hard to do on IXL because IXL just doesn't have a lot of these practice questions, because these practice questions are very novel, meaning every single one I can come up with is slightly different than maybe one you would see on a test. They're just all a little bit different. Okay, so looking at this worksheet, I want to make sure we go over like one from each kind of section. So questions 1 through 4, which one do you have a question on? All of them, I know, because yours is blank right now, but let's pick one to look at. You guys. Number 4? Okay, so number 4, write the interval that represents all real numbers except 2. So basically this implies that I have a number line, and then I have 2, and I want all of the stuff before 2 and all of the stuff after 2. So what I need to do is break this into 2 separate intervals. I have this interval here, and then this interval here. So to write it in interval notation, I need to know what is all the way down here. Negative infinity, right? If this arrowhead is shaded in, that arrowhead represents negative infinity. So I want to go all the way from negative infinity up to, but not including 2. So because of that, I put parentheses around it. Right? A bracket, a square bracket would imply that I'm including 2, but since I don't want to include 2, I then jump and talk about, okay, what's this interval? Well, I start at 2, and I go all the way up to positive infinity. And because this is math, right, and math has kind of new symbols that represent words, I put a U sign in between to show the union of those 2 intervals. Okay? So it's getting used to this notation, and really the only way to get better at it is to keep practicing it. I know it's kind of boring. We're going to practice with it again today. We're going to put it to word problems. So rather than maybe a number line, I'm going to give you a function and say, okay, write intervals that do X, Y, and Z. All right, that was 1 through 4. How about, do you want to do 5 or 6? Let's do 6, all right, sounds good to me. So for number 6, I have kind of this crazy function. Here's the problem with functions. I could keep showing you examples. I could still come up with something that's brand new that you've never seen before. This is called an exponential function because my exponent is the x value. So what I'm doing is this function keeps getting bigger and bigger and bigger as we go to the right. But let's talk about domain. Domain is all your possible x values. So what can I plug in for x into this equation?
I don't know if I got this right, but negative infinity?
Yes. I can plug in anything I want in for x. And so the way I show anything I want, I go from negative infinity up to positive infinity, and that's inequality notation. I then take this inequality notation and I write them as an interval. Now the nice thing about interval is I don't have to worry about the letter x. I don't have to make sure my inequality symbols are going the right way or the wrong way. That's all I have to do for that one. Now my range is different. I don't get out all of the answers, right? Look at this function over here. It's right over here. Does it ever go down here? Do I ever get negative values? I never get out a negative value. It's just not possible. So my range, I get really close. I never actually touch 0. It goes from 0 up to positive infinity. Or, right, you don't have to write it this way. You could also write it as y is greater than 0. Either one of those notations is correct. So use the one that kind of makes the most sense to you. The nice thing about this version is that I can already take, well, I've already got my start and my stop, so when I write my interval notation, I just grab those values and put it in there. Now this one here, this is definitely a challenge question. This is one that when I collect this, and I'm going to grade this one myself just because I kind of want to see where we're at. So that means even for those of you who don't have it done today, do it so I can kind of see where what you're struggling with. We will need to come back and study this more, but I don't want to do that yet. I want to keep that for the review for the test because I have a feeling you guys are going to do just fine on 3, 4, and 3, 5. I kind of leave the easiest sections at the very end for this unit. This stuff is hard, all right? It really is challenging. All right, end behavior. So what end behavior means, as my x goes to negative infinity, so as I go left, where does my function go?
Down.
It goes down, but does it ever actually get it doesn't ever actually get to 0. The reason why I call this a challenge problem is because when we played the end behavior game, you only had 2 options, positive infinity or negative infinity. That is primarily what you will see. That is what you will see on your test. Let's look at this other one. As x goes to the right, does my function go up or down? Up implies positive infinity. Okay? So if your function goes up, it's positive infinity. If your function's going down, negative infinity. Yep.
So why is the 0 can never actually get to 0?
It approaches. So that's what this little arrow means, is what does it approach? So the function approaches 0, but it never actually gets there. And you can test it. Remember, this is a function. Everybody pick up your calculator and do 3 caret negative 200. I don't know, put in a big negative number. See what you get out. All this function is the exponent is your x value.
How do you do that?
So caret is right above the division symbol. Everybody get out something that's got like an E in the answer?
I got arrow.
Same.
I got
3
I got
caret.
like 3
Make sure you use the
point
negative numbers and negative button, not the minus button.
I got 3.7 E, like negative 96.
Exactly. So 3.7 E, 96. That means I have 0.0, I've got 96 of these zeros, and then I have 3.7. Right? So I've got all these extra zeros, which means I get these very, very small decimals, but it never actually gets to 0. This is why this was a challenge problem, because we just haven't seen a function like this. This is a crazy function. All right, let's flip over to the back. Yep,
So can we talk about range first?
this range.
Yeah.
Yep.
Did you only put 0 there because it approaches it again?
It never actually hits 0.
Okay.
That's like your start and your stop, right? Your start is down here. The lowest it gets on the y-axis is 0. The highest it gets is positive infinity. Other questions? All right, let's flip it over. Let's do 7 or 8.
8.
8 it is. 8 again. Looks a little funky. Is this a function though? Does it pass the vertical line test? Yes, it does. So this is a function. It's a weird one. I know it's a semicircle. It's a half of a circle, but okay. When you see functions like this, where they are just like segments, right? There's no arrows going on and on forever. Everybody draw a rectangle around the function. Meaning every single point of the function has to fit within your rectangle. Here, you drawing a rectangle?
Yeah.
Okay. The reason why we're going to do this, it's going to stand out to us on my x-axis. Remember, domain is your x values. So look at your rectangle. What's the smallest number on your x-axis it hits? -4. What's the largest number? 4. So the thing is, it asks for set notation, which means set notation is the fancy notation. I have a curly brace. This says for all real numbers x such that, and then I put in my start and my stop with an x in between, and always, always, always less than or less than equal symbols. How come I did less than equal to and not just less than? Because the circles are filled in, right? I am actually including those points, so I want to make sure I do. Now your range is your y values. So you just look on your y-axis, what's the lowest it goes? 0. What's the highest it goes? 4. So I have for all real numbers y such that, and we go all the way from 0 to 4. Again, it had to be in that fancy notation. Now, why is there no end behavior? Why didn't I ask that question?
I don't know. It doesn't.
Both points end on
They're
the
both
x-axis.
That's a good question.
These are all really good
I
ideas.
put because it has endpoints.
It has endpoints, yes. Look at all of the other ones that we've studied so far, right? On this previous example, we got arrowheads going on in both directions, right? Those imply infinity. It's going to approach something. This one, arrowheads. This one, arrowheads. So if you just have a start-stop point, if you just have these endpoints, there is no end behavior. That is it for your function. It doesn't go beyond that. That is the end, yeah. I don't have to explain the end behavior because you can see it all right here. All right, looking at 9 or 10, which one? 10 looks harder. All right, let's do it.
I kind of get confused on both of those.
That's okay. These are tricky questions. All right, I have a function. It is a linear function. This is already in the format that we like, mx plus b. So therefore, I have to practice. This is good practice for your final exam, I'm telling you. Remembering Unit 1, how to graph a line. You plot the y-intercept. So I'm going to plot my y-intercept first, which on the y-axis is 1. And then I use my slope from my y-intercept to go up 3 to the right 2. And I'm going to do the same thing down 3 to the right 2. Maybe I'll just keep making it. We're going to talk about what happens in a second because yes, we are restricted right here, but we haven't figured it out how to do it yet. So I've got my line graphed. This is Unit 1. I would expect everybody in this room can do this, especially now that we've had a refresher how to do it. Now, I want to restrict my domain to only the x values greater than -2. So I pick up my eraser, and I find x equal to -2. It's right here. That tells me everything below, it doesn't exist. Now, because, remember, this is greater than, it's not greater than and equal to, I put an open circle right there because I don't want to actually include the value at -2, but I do want to include -1.9, -1.5. I've got to include all those pieces. Now the final piece is we have to figure out the range. So let's look at our y-axis only. What is the lowest it goes on my y-axis? It goes to -1, but it also goes to all this stuff in between here. So I'm going to say y is greater than -2, and because we need to have it in the same form, it's in set notation here, set notation here. You can either write it this way, or you can do the whole -2 up to positive infinity, whichever makes the most sense to you. So that's totally fine, but it's going to be wrong on the test. So here's what, because I get why we see the top value first. When you write it like that, just come back around to it and say, did I put the smaller number first? Okay?
Yeah.
Because I don't want you to not write that down, because that is the correct answer.
I
It's
just-
much easier to go back. Like, before you guys hand in your test, I will probably say, double check that your smaller number is first. You always want to put the smaller number before the larger number. But sometimes when we first see the answer, it doesn't stick out to us like that. So I will probably tell you to do that. All right, we're not going to do this one because we're going to do another example of how to take words and put it on there. I think you can do it, okay? I think you can do it.
Can I get over 9? Maybe?
No. I don't want to, I need to leave some out there for you guys to try on your own just so I can see how you're doing. I'm not trying to punish you. I really just, I'll let you see it, but really I need everybody in the class to try this on their own so I can see how they're doing. If you would like to turn in this homework, put it on your desk. I will collect it at the end of class. Otherwise, take out your notes. We're going to do 3.3. 3.3. Where we're going to be able to determine the characteristics of functions and calculate linear regression. Yep, these are some fancy words. We have 2 learning targets. The first one, though, I'm hoping allows you to kind of rely on your common sense, your understanding of how kind of math works. Okay, normally students don't struggle too much with this once they see, oh, this is like a science ACT. Like you show me a function and then I have to figure something out from it. That's from one unit, yeah. All right, everybody turn to 3.3 in their note packet. I know, Monday morning, only 7 of us here. Still got to get to work. All right, let's look at our warm-up question. What type of function has no minimum or maximum value? You can draw it, you can name it. What are we thinking? So we've studied parabolas, right? Parabolas can be like this or like this. Do those have a minimum or a maximum? Yeah, right? When it dips down, that's a minimum. When it goes up and then comes back down, that's a maximum. So the example function that we have studied, Unit 1, a linear equation, does not have a minimum or a maximum. It goes on and on forever in both directions. So you can't ever determine what its minimum or its maximum is. Okay, we're going to look at this funky function over here. Yes, it's a function. It passes our vertical line test. And we're going to answer some questions about it. Notice that every question that's being asked has the x value as what I refer to. From that x value, I look to see if the function is increasing or decreasing or positive or negative, whatever the case may be. All right, so letter A says the values of the function on the interval from x between 1 and 3. So I look over here at my function and I say, okay, between x is 1 and x is 3. Is my function positive or negative? Who thinks positive? You guys have to guess. It's either one or the other. Who thinks it's negative? Mason, you didn't vote. Okay, let's talk about what I mean by positive or negative. The output value, meaning the y value. So let's look at when x is 2. When x is 2, right, that falls in between 1 and 3. What is my y value? 1. Is 1 positive or negative? Positive. Our answer is positive. Let's look at our next example. Between 6 and 8. I come over here between 6 and between 8. And the question is asking, is the function increasing or decreasing? It is decreasing, right? I read it from left to right just like I would a book. I'm going down as I read from left to right, so therefore it's decreasing. This is where I say you guys can use your common sense on these questions. You got this, I know it. All right, now rate of change. That's a fancy word for slope. So we're just going to count our rise over our run between 8 and 10. So what I do is I say, okay, here down here at 8, let me make that an actual color, right? Here to here, I need to count my rise over my run. Now the problem is, look at the scale on the x-axis. It goes up by, every tick mark is 1. But what are the tick marks on my y-axis?
0.5.
They're 0.5. So this is what an ACT question will do, right? Your axes will be of the wrong or different units. So when I go up, it looks like I'm going up by 4. I'm really only going up 2. So I go up 2 and to the right 2. So 2 divided by 2 is just 1. So really, regardless of whether it's a line or not, you're just counting your rise over your run when it says rate of change. What is the value of the function at the points where the function changes from increasing to decreasing? So when it says what is the value, it means what is the y value. So as I go from increasing to decreasing, when do I know to kind of bounce down? At 1. And then how many x-intercepts? Just count them. How many we got? Yep, I've got 6 of them. Questions on that? That's what a lot of your homework is.
How'd you feel that?
The x-intercepts? 1, 2, 3, 4, 5, 6. Now, if that had been an open circle, I wouldn't count it. But since it's closed circle, I just count the number of times it hits the x-axis. All right? All right, let's move on to one of these where I give you a bunch of words. I know, these are ugly. This is the thing. Does anybody want to read this? No. It's a Monday morning. None of us want to read this. But if I showed you a graph of like measles outbreaks in the 1970s, you wouldn't have to read all of this. You could just get it all from the graph. So that's what we're going to do. So bear with me. I'll read it and we'll just, start graphing as we go. The incidence of a disease is the rate at which the disease occurs in a population. In 1974, there was an estimated 10 cases of measles per 100,000 people. Notice my time along the bottom here is reset. 1974 is time 0. So therefore at 0, I'm up here at 10. From 1974 to 1980, there were drastic fluctuations in the incidence of measles in the United States. In 1975, there was a slight increase in the incidence from 1974. So what is if it's 1975, what time is it on the bottom here? 1. So I'm just going to a slight increase. At 1, it's a slight increase, whatever that means. The next 2 years saw a substantial increase in the incidence, which reached a maximum in 1977 of about 26 cases. So 1977 represents what year down here? 3. So at 3, I go up to about 26. From 1977 to 79, the incidence fell to about 5 cases per 100,000 people. The incidence fell much faster from 1977 to 1978 than from 1978 to 1979. Perfect. So by 1979, which is at 5 years, we're up here at 5. And it said that it fell more drastically, kind of within the first of those 2 years. Finally, from 1979 to 1980, the incidence stayed about the same. So looking at this, what do you think happened in the year 1977? What did you say? We're talking about the measles here. It spiked. Why would it have gone down?
Vaccine.
That's when they released the vaccine for the measles, right? My goal next year, well, hopefully next school year, I'll swap this out with the story of COVID, and hopefully our vaccine story will say the same thing, right? Look at how significantly it dropped. Now, measles and COVID are very different, but still, one can hope, okay? On the y-axis, the function will run, sorry, yours should say 5. I think I fixed this typo in your notes, but I didn't fix it on my screen here. So here's my function. I'm going to draw kind of a box around it. So let's look at my y-axis. It goes from 5 all the way up to 26. And when it's the y-axis, when we're talking about the values that you get out for y, is it domain or range? Range. Perfect. The graph is horizontal from 79 to 80. What does this tell you about the rate of change or the slope? What is the slope from 5 to 6 here? 0, right? There's no rise. There's a run, but there's no rise. So it's just 0. This is what I mean about this unit. Use kind of the understanding that you have about functions. We're going to do, instead of just jumping to, so that was our first learning target. I want to do a little bit more practice though. So I'm going to give you this little half sheet.
So this is the second.
Exactly, yeah.
Foldable here.
Yes, I know there is a foldable. I'm not going to give that to you yet. I want to do a little bit more practice with this stuff. Because like I said, there's so many different functions out there. I can come up with new ideas all the time. So it's hard to always know, right, how to tell you the perfect way to do it. So let's do these together though, or at least the first half we're going to do together. What I'm looking for is I'm looking for these to be intervals. These two things here are going to be intervals, and then these two here will be intervals. Meaning, we have to write it in one of the notations that we're used to. Which notation would you like to use? I don't really care. We got our inequality. That's like 3 to 5. We've got set, for all real numbers, x, 3 to 5. And then we have interval, where we don't have to worry about x's or less than or equal to greater than or anything like that. We just this. So which one of these 3 would you like to use? Interval. I heard one interval. Is everybody okay if we do this with interval? All right. Because it doesn't say, you can use whatever notation you want. So the says, when is the function? These are always, what we're looking for are, what are the x values where this statement is true? The whole idea is I know the y values are positive. So looking at this graph, for what values of x is my function above the x-axis? Here's how I recommend you do it. Write on it, right? Here's where my function starts going above the x-axis. And then during this whole time, right, it is above our x-axis. So I just look at the x values. Here, sorry, hopefully you can read that, it's a -6. Here, I know, doesn't it look like a 4?
Yeah.
I scanned this in from an old textbook, that's what you get. So I go from -6 all the way up to +6. And I don't include -6 or 6 because the value right here is 0, right? This is the point -6, 0. Is 0 a positive number? 0 is a weird number. It's neither positive nor negative, so I don't want to include it. Questions on where we got that? Okay, let's look at the negative part, because the negative part is a little bit harder. When is my function below the x-axis? Here's the thing. I have two separate intervals. I have to write these as two separate intervals and connect them together. This has an arrowhead on it. Hopefully you can see it. What is my start number? Negative infinity. That's right. All the way up to negative 6. And then I go from 6 to positive infinity. And when I want to connect two intervals together, I put a U in between. That is pretty tricky. I want you to go ahead and try the rest of these on your own. For the zeros, you're just writing the x-intercept. Just write the number. Maximum and minimum, well, I'll tell you right now, this is a trick question. There's no minimum. But find the coordinate point that is the maximum. One more minute, then we're going to go over it. I just want to know when it's going up. You tell me for what interval it's going up. Yeah, go ahead, just trace it on the function itself. There you go. Now, you also should include down here, isn't it still going up and down here? All the way up to, no, I will worry about the x value. All right, I think I see, as I'm walking around, I see some correct answers and some incorrect. Okay. So what are my x-intercepts? Just shout one out. Negative 6 is one. What's the other one? There you go. Perfect. So those are your x-intercepts. You can write them as coordinate points, right? All fancy. But that's just where it hits the x-axis. Now I want to know for when the function is increasing. So what I like to do is I like to trace my function, right? All the way from out here, and my function is going up, and then it is done going up. It is not increasing anymore after that. I only care about the x values. So what is my x value all the way down here? Negative infinity. What's my x value right here? 0, not 6. That's my y value. I just care about the x values. So it's negative infinity up to 0. Now it's decreasing from here to here, and that goes from 0 to positive infinity.
Even if it's decreasing?
It is decreasing.
Oh.
That's what I want to know. Okay? Believe me, I'm doing this because your homework looks a lot like this. So use this little half yellow sheet to help guide you. My maximum, you can just write it as the coordinate point, 0, 6, or just 6. Either way, I don't care. Whichever one makes the most sense to you. All right, flip it over on the back. We have this whole read it and draw it. So I'm going to give you guys 1.5 minutes to read it and draw it yourself, and then I will draw the answer up on the board so you can check your work. All right, here's what I'm expecting. So grocery store stock shelves with 100 cartons. So we start the day with 100 cartons of strawberries. For the first 3 hours, the store sells 20 cartons per hour. So 20, 20, 20. You could have just gone all the way down to 40 by the time. That's fine.
Oh, shit.
Over the next 2 hours, no cartons of strawberries are sold. Perfect. The store then restocks 10 cartons each hour for the next 2 hours. So 10 more, 10 more. And then in the final hour that the store is open, 30 cartons are sold. Here we go. Then I just simply connect the dots. Okay? You will have a question like that on your test. It really is just taking the time to draw out all your little dots and then connect them when you're done. Think of it, right, as something my 8-year-olds would love doing. They didn't have to read all the words either. So I'm hoping kind of with this half worksheet and the notes we did, you guys will feel a little bit more confident doing the homework. We do have one more learning target to tackle, and that is calculating linear regression. You will need your calculators for this, because linear regression, and I will give you all the instructions on your test on how to do this, so you don't have to memorize. But what I did give you is kind of an example here. This is the foldable. If you guys would like to paste it, I have a bunch of glue sticks I can give you at the end of class if you want to paste it in. This is how you create a scatter plot and a linear regression on our old school graphic calculators. They're not that bad. The thing to note is, like, why do we need to calculate linear regression? Why is this something that's important to the world around us, right? We should always be asking that. I don't know. Let me try to think, what's a good example of something? Okay, let's say you've got your coordinate plane here, and on your x-axis is the number of e-cigarettes that you smoke a day. Okay? And then on your y-axis is your life expectancy. You do not have to write this down. So life expectancy is how long you live. And we don't know a lot about e-cigarettes, right? Like we assume you're kind of taking in stuff into your lungs, probably not great for your health. But so what scientists are doing right now is they're collecting lots of data from people that use e-cigarettes. And they say, all right, how many e-cigarettes a day? This guy just passed away. How many e-cigarettes a day would you say he smoked? Oh, he smoked 10 cigarettes a day. That's not great. He died a little bit younger than we would expect. Maybe he's down here. And you talk to, this 95-year-old lady that just passed away. She didn't smoke any e-cigarettes, so maybe she's up here. So what we do is we collect data from people, right? And people represent all of these dots. And what doctors want to do is they want to say, well, if somebody comes into my office and they tell me I smoke 20 e-cigarettes a day, I can say, hey, you're shaving 15 years off your life by doing that, right? I want to be able to give them that information. So what we do is we take all of these points that represent people and we draw a line to it. And we give this line some kind of equation, right? And it's equation we've seen before, y equals mx plus b. And that way, when somebody comes into the office and tells me how many e-cigarettes they smoke a day, I can estimate how long they're going to live. Now, obviously, there's a lot more that goes into this type of stuff. But what we're going to do is just take some of these points and write an equation of a line so that if I have somebody else that comes in, I can say, oh, you smoke 12 cigarettes a day? I'll plug that in for my x value and get out how long I think you're going to live. I'm sorry, that's kind of a morbid example. That's just what came to mind. So we are going to be using our little tip sheet here. What I would like you to do is circle. We're only going to do 4 of the steps. I'm not going to make us plot the whole scatter plot. We are definitely going to do number 1, where we have to identify what's the x-axis and what's the y-axis. We are definitely going to do number 2. We have to enter the data into our calculator or else we can't analyze it. We are not going to actually graph the scatter plot. If you are interested, the directions are here, but I'm trying to minimize the amount of things we do with our calculator. We are going to have to turn diagnostics on. We want to calculate some fancy things using these calculators. By default, they are not set to calculate those fancy things, so we will have to do it together. And then we will be doing the linear regression. Those are the only 4 steps you need, and I will give you instructions on how to do this on your test. Let's use the example from our notes. So everybody turn to this example here. Our good old friend Shelley. Shelley has a less morbid setup than what Ms. Sedlick had here. She is studying the relationship of car mileage and speed. This table shows the data that Shelley gathered using her family's vehicle. Use a graphing calculator to create a scatter plot, find the linear regression, all that kind of fun stuff. So we all, right, have probably driven a car or at some point practiced it, right? Cars they get better gas mileage at certain speeds. And it's different for different brands and for different car types. And so Shelley collected this data. Not a great statistician. She only collected 5 data points. But hey, it's good for us, all right? Which one is my x value? Which one is my y value?
Speed.
Yes. The mileage depends on how fast I'm going, right? If I'm driving on the highway, I'm probably getting pretty good mileage unless I go over that threshold, right? Maybe I start going too fast, then it's using up a lot of my gas. So my speed is my x. What? Well, if there can be instances where you can reverse these variables around. And we will talk about stuff like that, where you can manipulate these and say, well, I want this to be my independent variable. We just have to switch things around when we do that, and we can. All right, we're going to skip this first question, and we're going to get right to entering this into your calculators. Now, all the other classes have been using these calculators, so let's clear the RAM. Second plus sign, 712. Go ahead and clear the RAM out. So got our first example here. We have already done step 1. We have already determined our x and our y. So we can go right to step 2. Let me pull up my calculator here, where I go to the stat button. Notice your stat button is right here in the middle of your screen. And then I click enter to get into my edit menu. Everybody should see L1 and L2. Does anybody not see L1 and L2? All right, L1 is your X. So put in your X information. So Shelly collected data, 30, 40, 50, 60, 70. Then I put my Y values into L2.
How'd you get over there?
I just use the arrow keys. Yep. 33. Anybody need a hand typing these in? Got them in there? All right, so we have successfully completed step 2. Now jump over to step 4 where it says turn on diagnostics. Does everybody see this little blue down here above your 0 that says catalog?
Yeah.
So I need to go to my second 0 to get to that catalog of menus. So second 0. And I want to turn diagnostics on. So I have to scroll all the way down until I get to the D's.
I didn't know there was this much technology in this thing.
It has a lot, so much more than you think. It's crazy. You just have to know how to use it. It's the hard part. All right, so I select that I want diagnostics on, and I need to hit enter until it actually says done. Until diagnostics are really on. Anybody need a hand in that? Got it on? All right, we have successfully completed step 4. Our last step is to calculate linear regression, step 5. So this time when I go to my stat menu, I use the arrow key to get over to the calculate menu. So I do stat and then arrow over to calculate and choose the 4th one down, linear regression. And hopefully you get out the same numbers that I get.
I lost it all.
Okay. Second 0, did you turn on diagnostics?
I tried to, and it was off, and I did it by accident.
Okay. So second 0, you must have turned diagnostics off instead of on. Choose the one that says on. Now go to stat. Button in the middle there. And then go over to the calculate menu using the arrow keys. There you go, calc. And then choose number 4. Anybody else need a hand? Everybody see these same numbers that I see. So this is the good and the bad, right? Our calculator does help us, but it won't just tell us the mx plus b equation. It tells us that it's in the form mx plus b. Your a is the slope, or the m value, and your b is your y-intercept. So this is giving me the equation. Let's write it down in our notes. And I'm not going to round, I'm going to keep it just as is. So the question B says, perform a linear regression. Write the linear model. It is y equals, let me make sure I write it down, negative 0.175x plus 39.85. Does everybody see where I got that from the calculator? And I just filled in the a and the b value. Okay. What is the domain of my function? Well, I look up here and I say, okay, what values for x did Shelly plug in? Her lowest number that she collected data for was 30, And the highest number that she collected data for was 70. So that is her domain. That is the amount of information she collected. Letter C says, what can you say about the goodness of fit? So this is talking about, have you guys ever heard the word correlation? How well do things correlate? Well, I come back to here, and I look at this last number R. R stands for correlation. Why didn't they call it C? I have no idea. Correlation. If I get an R that is either close to -1 or +1, we've got a good model. So, do I have a good model or a bad model? Good. It's really close to -1. So, come on. Where you at? Where's my board here? Come on. I know you're down here. I know you're down here.
Okay.
Oh, of course, as soon as I walked away. So we would say good fit, R equals -0.98, which is close to -1. Letter D says, predict the gas mileage at a speed of 20 miles per hour. Let's look up at the table. Did Shelley collect data for a 20-mile-per-hour car? No. So how can I predict? How can I use my linear regression model? Yes, I plug in 20 into my equation for x. So I'm going to calculate. I'm going to have to pick up my calculator, multiply this out. So we got -0.175 times 20 plus 39. I get 36.35 miles per gallon. Anybody have questions on how I did that? And looking at the chart, that kind of makes sense. But to be honest, right, once you start going really slow, your miles per gallon actually doesn't necessarily get better on your car. It's not as linear as we want it to be. It gets worse is what it has a bit more of a parabola shape. Then this last question here says, we plugged in 20. Is 20 inside my domain? No, right? My domain goes only from 30 to 70. So it's this fancy word called extrapolation. Extrapolation is what statisticians do all the time. Okay? For so many years, and still today, when like medical professionals do experiments, they do them on men, predominantly, right? Because women, we get pregnant. And so a lot of times they don't include women in their studies. But then they make these big overarching like ideas, right? We should drink less Coke. We should, whatever the thing is. And they have to extrapolate out to women who weren't even involved in the original study. And so when you extrapolate out, you're making a lot of assumptions that we're all the same. And that's not necessarily true, right? Shelley is making an assumption that her model will work for 20 miles per hour. But that's just not the case. You always want to try to stay inside your domain rather than extrapolate out. Good job today. I know that was a lot, especially going over 3.2 so much. Here's your homework. The back has 2 examples that are these linear regression models. So you may want to do the back first since you have your calculator here and need help. Up to you. I will put out the keys so you can check the work as you go.